Another video for class 11. Here's the first example. This is from Hibbler's 12th edition. This is problem 1564, where ball A has a mass of 3 kilograms, even though he looks the same size as as B, and is moving with a velocity of 8 meters per second when it makes a direct collision with ball B, which has a mass of 2 kilograms, so that would be less. And is moving with a velocity of 4 meters per second, but the other direction. I guess it's that direction from where you're looking. With a coefficient of restitution of 0.7, determine the velocity of each ball just after the collision, and neglect the size because we're still dealing with particles. So let's take a look. They almost lined up with each other. That's kind of cool. All right, so I'm going to write out my initial, my impact, or we could say that it's the impulse, and then final. So I want to keep track of stuff. And if you don't know the direction of something, you should, in the after, we'll get to that here in a second, we want to probably draw those in the positive direction. So let's define what positive and negative is right here. We'll just say x positive here. So we have M, A, V, A, 1, M, B, whoops, I drew that the wrong way. We do know which direction that's going to be. Oh, blurry. Then we have kaboom right here, right? So we have equal and opposite impacts. I would put a negative in there, but that arrow makes it negative, so that's fine. So here, I'm going to predict this one's going to bounce that back way because that's lighter, right? So I'm going to say that that's MB, VB2, but I'm not sure. This one is so large that maybe it just slows down. So let me go ahead and make this one assume this is going positive. And then if we get a negative number, we know it will. It is actually even possible that it would completely stop if the numbers were just right. You could imagine these things are coming here and it's go boom, and that one would move along here. So we actually have an applet where we can try some of these things. I don't know if we could try them in class. I might try it out on my phone and see if we can do some of these things. Maybe we need to have some in-class activities coming up pretty soon. So I'm doing this whole thing. Maybe I should write out the big equation right here. This is the M, VA, oh, I didn't mean VA. Sum of the particles of the momentum, right, 1 plus the integral f dt equals summation m v2, right? That's the big equation, the big idea right here, but we know that's going to go away. And we know that we're only dealing with the x direction here. So let's write them out right here. M A VA1 plus, well, let's go ahead and put them as the signs. Here's a good place to put where the signs are, I think, as we're coming through here. Or we could put them into the velocity when we go down to there. It's going to be equal to MA VA2 plus MB VB2. So I'll stick the numbers in. We have 3, and it's traveling at 8. But now we have 2, and it's traveling at 4. And that's going to have like 3 traveling at we don't know, plus 2 traveling at we don't know. So my one equation, as I like to write it, I'm going to go 3 VA2 plus 2 VB2 is equal to, comes out to 16. So that'd be equation 1. Now we need to use the coefficient of restitution. I like to write it as the core right here. And we could write this in a couple different ways. I like to write it sometimes just to remind myself. Sometimes I write it this way. Sometimes I write it this way. But most of the time, I will write it this way right here. remember, we need to reverse the order of these. So, and that's going to equal to 0.7, right? We were told the coefficient of restitution. So that equals VB2 minus VA2 over 8 minus 4. That's important, right? These still have the direction in them. All right, so what we're left with is B2 minus A2, and that's divided by 12 right here. So that's like equation 2, and I guess I decided to write it out again. So I have B2 minus VA2 is going to be equal to 8.4, right? Because we multiplied 0.7 by 12. So that's equation 2. Two equations, we can plug them into each other. So we write this down. We solve 1 and 2, right? And what we're left with is VB2 is going to be 8.24 meters per second. So it really took off right there. And this is a vector because we gave it magnitude and direction right here. And when we go ahead and plug this back into really either of these equations right in here, we're going to see it's like, wow, this thing took up most of it. And this guy, VA2, we will find is a negative 0.16 meters per second. So VA2 is 0.160 meters per second. And it does start to bounce backwards, but not by a whole lot, right? So that's example 1. I'll make a separate video for example 2. It's only 7 minutes, but 7 minutes, that's the amount of time.